Class 7, Maths, Chapter 7, Congruence of Triangles. Animated Math, Introduction. Now we shall learn a very important geometrical idea called as congruence. Particularly, we shall study about congruence of triangles. To understand what is congruence, let us do some activities first. Activity 1. We take two stamps of the same denomination. Place one stamp over the other. What do we observe? We observe that one stamp covers the other stamp completely and exactly. This means that the two stamps are of the same shape and same size. Such objects are said to be congruent. Congruent objects are exact copies of each other. Activity 2. Take two biscuits of the same packet. Place them over each other. Again, we observe that one biscuit covers the other completely. So, these two biscuits are of the same shape and same size, or we can say that they are exact copies of each other. Hence, they are congruent objects. Such activities we can perform with two erasers of the same brand, two textbooks of Standard 7, etc. From all these activities, we learn a few things, and that are: congruent objects are exact copies of each other. Relation of two objects being congruent is called as congruence. In this chapter, we shall deal with congruence of plane figures only, although congruence is a general idea applicable to 3D objects also. So let us start with our first subtopic, congruence of plane figures. Congruence of plane figures. Look at the two figures given below. Are they congruent? We can use the method of superimposition and find out. If the two figures cover each other completely, then they are congruent. Note: one is not allowed to cut, bend, or stretch the figure cut out. For these two figures, we can say that they are congruent. Congruence among line segments. Condition for congruence of two line segments. If two line segments have the same length or equal length, they are congruent. If two line segments are congruent, they have the same length. Look at the given figures. Try to find whether they are congruent or not. We can see that one pair of line segments is equal, so we can say that they are congruent. Congruence of angles. Condition for congruence of two angles. If two angles have the same measure, they are said to be congruent. If two angles are congruent, their measures are same. Look at the two figures given below. Try to find out if they are congruent. We can see that one pair of line segments is equal, so we can say that they are congruent. Congruence of triangles. Till now we have seen that two line segments are congruent when one of them is just a copy of the other. Similarly, two angles are congruent when one of them is a copy of the other. We can extend the same idea to triangles. So we can say that two triangles are congruent if they are copies of each other, and when superposed, they cover each other exactly. Now consider triangle ABC and triangle PQR. They have same shape and size. They are congruent, so we express them as triangle ABC is congruent to triangle PQR. It simply means that when we place triangle PQR on triangle ABC, P falls on A, Q falls on B, and R falls on C. Also, PQ falls along AB, QR falls along BC, and PR falls along AC. If under a given correspondence, two triangles are congruent, then their corresponding parts or angles and sides that match one another are equal. Under a given correspondence, even matching of vertices is important. Example: triangle ABC and triangle PQR are congruent under the correspondence. ABC is congruent to RQP. Write the parts of triangle ABC that correspond to P, Q, and RP. Solution. For better understanding of the correspondence, let us see this diagram. The correspondence is ABC is congruent to RQP. This means A is congruent to R, B is congruent to Q, C is congruent to P, PQ is congruent to CB, Q is congruent to B, RP is congruent to AC, P is congruent to C. Criteria of congruence of triangles. We make triangular structures and patterns frequently in our day-to-day life. So it is rewarding to find out when two triangular shapes will be congruent. If you have two triangles drawn in your notebook and want to verify if they are congruent, you cannot every time cut out one of them and use method of superposition. Instead, if we can judge congruency in terms of appropriate measures, it would be quite useful. Let us try to do this. SSS Congruence Criterion. Side, side, side. Under a given correspondence, two triangles are congruent if three sides of one triangle are equal to the three corresponding sides of the other. Example: in triangles ABC and PQR, AB is equal to 3.5 centimeters, BC is 7.1 centimeters, AC is equal to 5 centimeters, PQ is 7.1 centimeter, QR is 5 centimeter, and PR is 3.5 centimeters. Examine whether the two triangles are congruent or not. If yes, write the congruence relation in symbolic form. Solution: here AB is equal to PR, which is 3.5 centimeters. BC is equal to PQ, which is 7.1 centimeters, and AC is equal to QR, equal to 5 centimeters. This shows that the three sides of one triangle are equal to the three sides of the other triangle. So by SSS congruence rule, the two triangles are congruent. From the above three equality relations, it can be easily seen that A is congruent to R, B is congruent to P, and C is congruent to Q. So we have triangle ABC is congruent to triangle RPQ. SAS Congruence Criterion. Two sides and included angle. Under a given correspondence, two triangles are congruent if the two sides and the angle included between them in one of the triangles are equal to the corresponding sides and the angle included between them of the other triangle. Example: in the given figure, AB is equal to AC and AD is the bisector of BAC. State three pairs of equal parts in triangles ADB and ADC. Is triangle ADB congruent to triangle ADC? Give reasons. Is B equal to C? Give reasons. Solution: the three pairs of equal parts are as follows. AB is equal to AC, given. BAD is equal to CAD. AD bisects BAC and AD is equal to AD. Common. Yes, triangle ADB is congruent to triangle ADC by SAS congruence rule. B is equal to C, corresponding parts of congruent triangles. ASA Congruence Criterion. Two angles and included side. Under a given correspondence, two triangles are congruent if the two angles and the side included between them in one of the triangles are equal to the corresponding sides and the angle included between them of the other triangle. Example: in the given figure, can you use ASA congruence rule and conclude that triangle AOC is congruent to triangle BOD? Solution: in the two triangles AOC and BOD, C is equal to D, each 70 degrees. Also, AOC is equal to BOD, equal to 30 degrees, vertically opposite angles. So, A of triangle AOC is 180 degrees minus 70 degrees plus 30 degrees, which is 80 degrees, using angle sum property of a triangle. Similarly, B of triangle BOD is equal to 180 degrees minus 70 degrees plus 30 degrees, which is equal to 80 degrees. Thus, we have A is equal to B, AC is equal to BD, and C is equal to D. Now side AC is between A and C, and side BD is between B and D. So by ASA congruence rule, triangle AOC is congruent to triangle BOD. Congruence among right-angled triangles. Congruence in case of right-angled triangle becomes easy because the right angle in both the triangles are equal. Rhs Congruence Criterion. Right angle, hypotenuse, and one side. Under a given correspondence, two right-angled triangles are congruent if the hypotenuse and one leg of any one of triangles is equal to the hypotenuse and the corresponding leg of the other triangle. Example: in the given figure, DA is perpendicular to AB, CB is perpendicular to AB, and AC is equal to BD. State the three pairs of equal parts in triangle ABC and triangle DAB. Which of the following statements is meaningful? Triangle ABC is congruent to triangle BAD. Triangle ABC is congruent to triangle ABD. Solution. The three pairs of equal parts are ABC is equal to BAD, which is 90 degrees. AC is equal to BD, given. From the above, triangle ABC is congruent to triangle BAD by Rhs Congruence rule. So statement 1 is true. Statement 2 is not meaningful, in the sense that the correspondence among the vertices is not satisfied.